Hello. Mm, Arrays and hashing. So we have solved 1, 2, 3, 4, 5, 6. 6 questions till now. We'll solve product of array except self. Product of array except self today. Medium difficulty. I've already solved it before, but it was a long time ago. So this would be a great practice for me. Okay. So we have an integer array nums. we uh, we have an array as an input nums, and we have to return an array answer such that answer of I is equal to the product of all the elements of nums except nums of I. So our solution should look like, so in the first position of the answer, right, we have to return the product of all the other positions of the array. So for the first position, we have to return uh, 2 times 3 times 4. For the second position, we have to return 1 times 3 times 4. For the third position, we have to return 1 times 2 times 4, and so on. I think we got the gist. So that's what the answer should look like. So brute force would be like the straightforward approach, that we would traverse the array. We would use two loops, and then we would just if we are if we have selected the first element, then we just have to multiply other elements. If we have selected the second element, then we have to multiply the other elements. So this approach again goes for O of n square number of times, which is not really optimized. um, yeah, we have an optimized O of n way of doing this. So let me go to the sketchpad. Right, this is our array and our test cases, example test cases. So one way of looking into this is, what if we multiply the whole array at once, right? Suppose if this so the multiplication of whole array of this is 24, right? 24. 1 times 2 times 3 times 4 is 24. So if we want the answer for position 1, we can just divide the position 1 here, right? So 24 divided by 1 would be 24. Then for position 2, we can just do 24 divided by 2, which is 12. So this is product of array except its own self, right? We are dividing the own self from the total product. So this way you might think that this way it is possible to solve it in O of n, right? 24 by 3 is again 8, which we have in the answer as well. 24 by 4 is 6, which we have in the answer as well. So this way it's possible, right? But then say suppose, what if, say suppose take the example 2. We have 0 in this example 2. So the whole product of this would be 0 only, right? And then if you want the answer for position number 1, we would do 1 minus 1 by 0, which is undefined. We can't divide any number by 0. That's not possible really. So this way of doing things fails when we have a 0 in the array. So we can't really do things this way. So another way of doing these things is we can use a prefix sum. So the approach that we can use this, right? Say suppose take this number 2. Hmm. On the right side of number 2, we have 3 and 4. What's the multiplication of 3 times 4? It is 12. And on the left side, we have 1. So just 1. 1 multiplied by 1 is just 1. So if you multiply 12 and if you multiply 1, what do we get? 12, right? And we need 12 only here. The same case for 24. Same case for 1. On the right side of 1, we have 2 times 3 times 4, which is 24. Left side has nothing, so we'll just take 1. So 24 times 1 is 24, right? So what we need is, for each number, we need the left side multiplication of it, and we need the right side multiplication of it. And so if we multiply these two things, we'll get our answer for the current array. So my approach would be to first do the multiplication from the left side and store it in an array. Like suppose left multiplication. We'll store the multiplication one by one. So first position would always have the same number, say suppose 1. Second position will have this number, sorry. First position will always have 1. Second position will have the first, so the previous stored number times this number. Previous stored number times the first number. So 1 times 1 would be 1 here. For 3, we have 1 times 2. The previous number is 2, right? So we have 2 here. And for 4, we have 2 times 4, which is 8. Okay. For right multiplication, we'll start from the right side. We would have 1 first, because before this 4, we have nothing to multiply to. Then we'll multiply this one by 4. We'll get 4 here. Then we'll multiply this 4 by 3. We'll get 12 here. And then we'll multiply this 12 by this 2. So we'll get 24 here. Okay. And then we'll multiply uh, 1 times 24 to get the answer. So we have res. Okay. We'll get 1 times 24, which is 24. We'll get 1 times 12, which is 12. We get 4 times 2, which is 8. Oh, why is this 8 here? That's wrong, right? We need 6 here. What mistake did I do? 2 times 3. Oh, 2 times 3 is 6. Stupid. Right. 2 times 3 is 6. So 6 times 1 is 6. We got our answer, right? Let's try to code this. Okay. So we need left multiplication array, right multiplication array, and the res array. Right. Left multiplication array will have 1 already in the array. Right. Right multiplication array, I want to go from the, I want to do it from the right side, right? So I just make an array of the size nums. The size nums. Perfect. First, I will try to fill the left multiplication array for I in first segment I've already filled, right? I need to start it from the second element. Nums, nums. 2, no, 1. First element starts from, so second element starts from 1. And I'll multiply left one of I would be, so I'll multiply the previous value of left mul I minus 1 times I'll multiply the previous value of nums like this. Previous value of left mul and previous value of nums, which is 1. This is for the second element, right? That's why. Okay, previous element of nums. Yeah, I minus 1. So this would fill our left mul wala array. Sorry, left mul array. I have to stop saying wala and Hindi slangs and stuff. Len of num, sorry, len of nums. So the last element would already be filled. We have to start from the second last element, right? So len of nums minus 2 will go till the first element. So this loop will run in the reverse order, right? Null. We are trying to multiply from the right side, right? Right side is the reverse order. So right null of so you have to multiply the element before that, which would be I plus 1, and also multiply the element in nums before that, I plus 1. That meant nums would always have two elements, so this should work perfectly. So we have left null, right null of I. This would have given me a letter now. Now we'll try to multiply the value of left null and right null to get the answer. I can just store it in the left null or right null array. No need to create another array. Mm, yeah, then of nulls. Right. These questions I've already solved now, so it becomes a bit easier for me to do this in the format. I think once I get the hang of speaking, no, I'll start doing the unknown questions. And even so, in practice, I've already done this 8 questions. And besides from like the main topics, the other topics, I haven't solved any questions at all. So this would be very new venture for me. So after I've done with the solved questions, now I have to do these questions anyhow. The new questions, that is, just would be a challenge. Yeah. So our answer would be stored in the left null array itself. Return left null. Right. We should work. Oh, we have got assignment index out of range. Oh, we have to append. So, or else I can just do this also. Yep. Yes. So I can try to show the left nums and left null and right null array also, how it looks like before you multiply it. Right, I'm printing them. Yeah, so see, left null, na, we have the first value as 1 by default, and for right null we have first value as right value as 1 by default, because we don't have any elements uh, before 1 and after 4, right? And then we are multiplying this one with this one for the second value. We are multiplying this one by this 2 for the third value. So we are getting the product of product of the numbers before that number, right? The left side of the number. And for the right null array, we are getting the product of the numbers in the right side of the array. So that's how this is working. So this loop is only going one times throughout the whole array. We are running this for 3 times, so it's like O of log 3, sorry, O of 3n, but then we don't count the constants in the time complexity. So this is O of n only. And the space complexity is also O of n. So this is like the most optimized solution for this. Yeah, the time complexity is like not that good. But then yeah, everyone is doing the same thing only. So it's not that different. So yeah, that was product of air accept self. I think I was well versed with this problem beforehand only. So I think I was able to speak very confidently because of this. So I think if I practice the problems more and more, the patterns would become obvious and obvious, and then the confidence in speaking would come by itself only. That's what I think. So we'll only get to know that when I try to do the unseen problems for this. Hmm. So yeah, that was product of Arets itself. I think if this comes in the interview, I would do a good job for it. Yeah, that's all.